Okay, so we are going to look at some extra problems here for some extra practice. So this asks us to identify the limiting reagent and the excess reagent. Now, the excess reagent is one of the reactants on the left side that we will have extra of. Now, in the case of our chemistry course, we will usually be told that. So we can see in this problem that it says we have 10 liters of NO gas and an excess of oxygen gas. So that tells us that we have extra oxygen. And what that means is that when this reaction happens, we will have extra oxygen that isn't needed for that will be left over, I guess you could say, that will be left over. So our full product will be formed and we will have extra oxygen left over, as opposed to our limiting reagent, and that's what limits our reaction. So we would use all of it. And we would be told that in our problem because we would be told, like, for example, that we only have 10 liters of gas and we have plenty of oxygen gas to use with that 10 liters of NO gas, and we actually even have extra. So in this case, our limiting reagent is NO. I know that looks like no, but NO gas. Here we go. Then it asks us to find our theoretical yield, actual yield, percent yield. Now, theoretical yield, remember, we need to do our stoichiometry. Our actual yield means, okay, we either need to be in the lab and measure this, or we will be told. And so in most cases for us, we will be told since we're not in the lab. So it says we actually collected 8.50 liters of NO2. So again, remember, our actual yield is how much product did we actually gather? And this is our product. So our actual yield is equal to 8.50 liters of NO2 gas. And then remember to find our percent yield. Our percent yield is actual divided by theoretical and then times it by 100. So we need, in order to find this, we need to find our theoretical yield. So we're given liters of NO gas. I am going to actually move this writing down because I want to do, let's figure out what process we have to do. So number one, we're given liters of NO, and we need to get to, see how we collected liters of our product. So we need to get from liters of this to liters of that. So we're going to go liters to moles of this reactant. Then we need to hop over and get to our product. So we need to go from moles to moles. Looking at that mole to mole ratio. Remember when we would look at these guys. So this is step one, this is step two, and then we need to go from moles to liters, which would be step three. So let's get started. We are given our starting point of 10.00 liters of NO. Then, let's change colors here. We know that liters of NO has to be on the bottom. They have to match. And we need to go from liters to moles. So 1 mole of NO is always 22.4 liters. Then that cancels that out. Now we need to go from moles to moles. We need to look at that ratio, 2 to 2 ratio. And we got to make sure that we have the correct units. Moles of NO needs to be down here. So that means moles of my product, NO2, on top. And then finally, we got to cross those out. We need to go step 3, moles to liters. So 1 mole of NO2 on the bottom to 22.4 liters of NO2. And that will cancel these out. So let's do the math. And we got 10 point, let's see, how many sig figs do we have? We started with 4, so 10.00 liters of NO2 is how much we should get, which I guess makes sense when you think about it. I started with 10. My 2 to 2 ratio is essentially, that will reduce to 1 and 1. And I'm doing 22.4 divided by 22.4, which will also cancel out. So now let's figure out our percent yield. So let's erase some of this. Again, if you want to go back and look at this, feel free to go back and pause the video and go back and rewatch. I just need to have some space to work here. So we're going to do our actual. What did we actually get? We actually were told that we got 8.50 liters. What did I theoretically get by stoichiometry? I got 10.00 liters. That's my theoretical. And then times it by 100%. So when we do 8.5 divided by 10, we get 0.85 times that by 100. So I got 85% yield. Okay, for this next question, okay, so let's look at what we need to do here. We're told that we have 2.80 grams of aluminum is mixed with chlorine gas, forming aluminum chloride. So the very first thing we need to do is we need to write a balanced equation. It's important to do this because that's going to give us our mole ratios. All right, number 2. It says, after the reaction is over, 4.53 grams of aluminum chloride is collected. So that's my product. So that's telling me, what did I actually get? So this is my actual yield. Write the balanced reaction. Okay, so that was our number 1. Number 1. Determine the theoretical yield. So that means I need to go from grams of aluminum, so grams of Al, to moles of Al. And then I need to go compare moles of aluminum to moles of my product, right? Because we know how much of my product is actually collected. We need to figure out how much AlCl3 is theoretically collected by stoichiometry. So moles of AlCl3. And then, since this is in grams, I collected in grams, I need to get back to grams of AlCl3. So we also will need our periodic table. Here we go. So hold on. We have step 1, step 2, step 3. Because in order to go from grams to moles, we need to know what aluminum's molar mass is. So you need to look at the periodic table. PT for periodic table. Look at periodic table for aluminum's molar mass and then we also need to look at the periodic table for aluminum chloride's molar mass, because when we go from moles to grams, we need to know what 1 aluminum and 3 chlorine's molar mass. So I'm going to do MM for molar mass for AlCl3. So hopefully this mess makes sense, and take a minute and go through and do this, because this is your Canvas activity quiz. It will hopefully be a lot less stressful when you open up the quiz if you already have the answers. If you're not sure, I would recommend going back and looking at the previous lecture examples, doing some more practice problems, reading your book, or if you're still stumped, contact me, shoot me an email, come to office hours. But I'm hoping that you aren't getting too stressed out over the quiz and understanding this process.